All right, hello everybody. We'll get into our next section here, solving square root equations. So just as a warm-up, I want to just make sure we're comfortable in seeing the difference in each of these types of things here. The first one, part A, x squared equals 9. That's basically solving like a simple quadratic equation like we did before. And if you think about it again, you want x by itself. And if it's squared right now, square rooting it undoes that. But when you solve the equation, we do need to include the positive and the negative square root of 9. Which of course is 3. Okay, and the reason for that, because we're solving an equation, right? And if you check negative 3 in the original equation, right, the original equation is x squared equals 9. Negative 3, when you square that negative number, does become positive, so it does solve the equation. Okay, part B looks a little different here. X to the 1/2 power equals 9. So in this case, we're not going to take a square root. Okay, we need it to be x to the first power, and it's right now x to the 1/2 power. Okay, so one way to think about that, something to the 1/2 power is actually the same as taking the square root. Okay, so to undo a square root, it's kind of the opposite of what we did in part A. The inverse of square rooting is squaring. Okay, so the squaring undoes the square root, and we're left with just x, and then 9 squared equals 81. Okay, and just one more side note on that. Sometimes these fractional exponents show up, SAT kind of thing or whatever. Just as a side note, like x to the 1, we said x to the 1/2 is the same as the square root. If you have something to the 1/3 power, it becomes a cube root, meaning, what times itself 3 times equals the x value. So really, whatever that denominator is in the fraction or the exponent, that's going to be, it's called the index of the root. A square root is technically an index of 2. We just don't usually write it. But if you get a full fractional exponent, like x to the 2/3 or something like that, again, the idea is the denominator becomes the index. It's a cube root of x squared. Okay, or it could be a cube root of x and the entire thing squared from the exponent up there. So again, we're not going to do a ton with the fractional exponents. You should have done a little bit more with that, maybe in Algebra 1 or whatever. But just as a quick recap, the denominator, again, is what becomes the index. Okay. Anyways, and then part C from our warm-up. So the square root of 9, of course, the square root of 9 is just 3. Similarly to what we did in part A over here. But just note, if it's just a square root, we don't have to include the negative 3. This is called the principal square root, and they just want the positive answer. Okay, we included the plus and minus over here because we were solving an equation, and we had to do the positive and negative square root of 9. Okay, so let's look at a couple other examples where we're solving a square root equation. Here's an example. This is in the text on page 391, and they kind of walk through some steps, and let's just kind of run through it, and then we'll do a few on our own. Okay, so the process is very much like solving just a regular standard equation. You want to get the variable by itself. But in this one, the variable is going to be underneath the square root symbol or radical. Okay, so you're going to want to get that by itself first. Then you square both sides, kind of like we saw in the one on the warm-up. We do the solution steps, and then this last thing down here, we do need to check for what are called extraneous solutions. Okay, and I think it's telling us over on the side here. I was going to explain, but it says right here, an extraneous solution can be introduced when you square both sides of an equation to eliminate the square root. Okay, the resulting equation may not be equivalent to the original for all values. So kind of a lot of words. Basically, it's saying sometimes you do all the steps correctly, and the answer just doesn't check. And it has to do with because when you square negatives, they become positive, and it kind of messes things up. So we'll keep an eye out for that when we do these. Okay, but here's a first worked out example A. As you can see, the radical, the square root symbol, of course, is just the x minus 3. So the very first thing we need to do is get rid of that plus 4 on the outside. So they're going to start by subtracting 4 before you do anything. Okay, and that's taking us to this step right here. Okay, and then what we're just doing is to get rid of that square root, just like we saw in the warm-up example, we will square both sides. So squaring the square root of x minus 3 makes it just become x minus 3. And then we have x minus 3 equals 25. Add 3 to both sides, we get 28. And then you do want to go down here and check your solution. Just make sure that it actually worked. Okay? Second example, you guys can take a look at the steps on that one. Let's see. Okay, so just notice on this one, one thing to point out, they do have the x plus 1 being raised to the 1/2 power. If you want to just rewrite that right away as being under a square root, it might just make the problem not seem as complicated, because that's really, again, the 1/2 exponent just means square root. So as you can see, the steps here, first step would be to subtract the 5 from both sides to get down here, and then you square both sides. Okay, and we'll do an example like this fully. But when you square this, make sure that you are multiplying the x minus 5 times itself and actually foiling out the whole thing, distributing it all out to get you this here. Okay, so just be careful. And then it turns into a quadratic equation, which is factorable. Get two solutions. They check them both out. It appears that the one solution of 3 did not check. Okay, if you can see down here, when they checked 3 into the original equation, didn't end up working. 3 ends up being extraneous. Okay, so you can pause the video or take a look at this one in the text if you want to look a little deeper. But let's do a few on our own where we do all the steps and see what's going on with these. Alright, so there's a few. Try these here. So let's take a look. So this one here, we have 2 minus, then the square root of x plus 1 equals -5. Okay, and what we want to do first, always get the square root, the radical symbol by itself first. So anything outside there, like a 2 sitting there, needs to be taken care of. So we will subtract 2 from both sides. Okay, we will be left with the negative square root of x plus 1. -5, take away 2 more, will get us -7. Okay, then I would suggest at this point we could, we may not want to have that negative outside there. Remember, this is like -1 times the square root. So we can divide both sides or multiply both sides by -1, which would kind of just get rid of the negative out front there, and it would make the 7 become positive as well. Okay, it's not changing the plus 1 under the square root, right? It's just changing we kind of just divided this coefficient by -1. Okay, so now we're ready to square both sides. The square root, is by itself. Okay, so when we square both sides, the square root of x plus 1, once we square it, just becomes x plus 1. Okay, all it does is make the square root symbol go away. The 7 squared is now 49. Okay, and we can, of course, subtract 1 from both sides and get x equals 48. Okay, so that's a potential solution. I'm telling you right now, you do want to check all these out because, again, sometimes you get those extraneous. Okay, how do you check an equation? Plug it into the original. Okay, so 2 minus the square root, x we're saying is 48, plus 1 equals -5. And since we're checking, we'll put a little question mark there and see, does this appear to be true? So if we simplify, 2 minus, so 48 plus 1 is 49. Does this equal -5? Okay, 2 minus the square root of 49 is 7. And 2 minus 7 is -5, so it does work. So our solution checked out. X equals 48. All right, let's take a look at another one here. So we have the square root of x plus 4 equals x minus 8. Okay, so this one has x's on both sides, so we're going to have to be careful with that. But now notice the side that does have the square root is already by itself. Okay, so we are ready to right away go ahead and square both sides of this equation. Okay, the left side, squaring it's just going to undo the square root. Okay, now squaring the right side, be careful. It's not just x squared minus 64 or x squared plus 64 even. There's going to be an x minus 8 times itself, which again needs to be distributed, or that FOIL process, right? X squared minus 8x minus another 8x, then the plus 64. Okay, still x plus 4 over here. So that right side of the equation, again, remember, is x squared minus 16x plus 64. So a lot of times people do that step in their head for some reason, and they miss the minus 16x in the middle, so don't let that happen. All right, now we're going to solve this like a normal equation. So I see that it has an x squared term in there. It's a quadratic equation. I'm thinking let's get it set up equal to 0. Okay, I'll start out by subtracting x. Okay, and then again, I need to have a 0 over here, so I'm going to minus 4, right? Just remember, anytime you have a quadratic equation, we get it set up equal to 0, so then we can try our factoring or our quadratic formula if we need to. Okay, so I got the equation set equal to 0. We have 0 equals x squared minus 17x plus 60. I'm going to hope that it's factorable because the quadratic formula would always take a little longer. So let's see. So factors of 60, right, that add up to negative 17. I think we could go with x minus 12 and x minus 5. Okay, 5 times 12 is 60, right? Negative, I should say negative 12 times negative 5. So our potential solutions are x equals 12, x equals 5. Okay, now comes that all-important step where we check our answers. And we have to check them both, one at a time. Okay, checking our work. So let's check x equals 12 first. If we check x equals 12 into the original equation, okay, original equation right here, we had the square root of x plus 4, so 12 plus 4. Does that equal 12 minus 8? So I'm putting in 12 for both x's and asking myself, is that true? So the square root of 16 equal 4, is that a true statement? Yes. Okay, so our x equals 12 works. Now let's check the other option. Let's check x equals 5. Okay, if we check that one, again, plugging it into the original, the square root of x plus 4, so the square root of 5 plus 4, does that equal 5 minus 8? All right, so let's check that. So the square root of 5 plus 4 is 9. Is the square root of 5, square root of 9. 5 minus 8 is negative 3. So is the square root of 9 equal to negative 3? And it's not, okay? Negative 3 squared does equal 9. But remember, the square root of 9 is technically only positive 3. So that's why you sometimes get these extraneous solutions, okay, where we didn't do anything wrong, we didn't make an error or anything. It just ended up happening that way because when we squared a negative number, it becomes positive. And you sometimes get these, again, extraneous is the fancy word. It just means that it doesn't check. It didn't really work. So make sure when you state your solution, you state that 5 was extraneous and the only real solution was x equals 12. All right, equation algebraically, we saw that it had two solutions, but one of them was extraneous. Okay, so let's talk about this same exact equation. Sometimes you can use graphing to solve equations or to like check your solutions and stuff like that. And this is actually a good tip if you're taking especially like a standardized test and it's a calculator portion where you don't have to show any work, you're just bubbling answers or whatever. You can always use a graph to kind of check things out. So let's think about this. Will tie into what we did in the first section. I'm going to graph both of these guys, okay? Just kind of a rough sketch. I'm not going to do a perfect sketch or anything, but the first one, okay, we should know from the last section what the square root of x plus 4 looks like, right? It's going to be a square root function that has been shifted to the left 4 units. So it's going to do something like this. It's going to start there, and all square root graphs always have that kind of shape. Okay, remember the basic shape of a square root function, and then the transformation, the plus 4, made it go left 4. Okay, the x minus 8, that's just a linear function. It would have a y-intercept down here at negative 8 and a slope of 1, so it would be doing something like this. Okay, now the reason that I graphed that, okay, and if I was more careful and tried to graph more accurately, I could have done that with graph paper or whatever, but I'm seeing one solution point right here, okay, just based on the way these things are shaped, right? The square root function kind of being this curvy kind of thing, like that, and then the linear, of course, like this. They're only going to intersect the one time, and that kind of just verifies what we saw when we did. So hopefully that kind of helps just as a way to maybe visualize the solutions.